Okay, hey everyone. This is gonna be for I'm not sure if it's chapter 4 or chapter 5, and I'll modify the titles of this PDF based off of what it is. But it's basically going over the things that you were trying to do in your quiz. And so the first thing was the chair confirmation. And so here we have an example of what your quiz question would look like. Let me see. These were the questions you were pretty much asked, and this is a similar compound to what you were given. So the first one is draw the chair confirmation. So some of the notes that I wrote down over here will give you a clue as to like how to approach this. And so whenever there's something on the dash, just know that it's going to go down on the chair, and when something is on the wedge, it goes up on the chair. And so over here I circled this dashed bond, and it's labeled as down. This methyl group is wedged, and so it's labeled as up. And so that's how you're going to have to draw the substituents on the chair confirmation when you're building the chair. And so you build the chair over here. You build your chair. You number it however you want. I like to number it starting with number 1 over here, and then I go clockwise with all my numbers. But you can number it however you want, as long as your substituents are pretty much like 1, 2, 3 carbons away from each other in this situation. So 1, 2, and 3. However you choose to number it will grade you accordingly. Like, it's gonna be right if it's right. Okay. So for the sec butyl group, we said it's gonna be down. So on our chair confirmation, we did it down. Down happens to be equatorial, and then whenever something is in the equatorial position, there's a little slant to it, and so this gets slant down. Axials are always going to be wherever the corners point. So like in this corner, the arrow is pretty much pointing up, and so our axial would be over here. So we would have an axial hydrogen over here, but we don't have to write it out. Same thing with this right over here. We said it was going to go up. The arrow is pointing up, so axial is going to be up. So then we had to draw our methyl group going up. Okay, so that's our first chair confirmation. Then we'll go to B. Draw your chair confirmation after a ring flip. So I flipped the ring. The lines were once going towards the right, and now they're going to the left. That kind of tells you that I flipped it. And once they flip, notice how I had 1 and 2 over here. Everything shifts down 1. So 1 is going to appear here, 2, and then I numbered clockwise. But still, we are expecting a sec butyl group on carbon number 1. And directions, notice how this little note over here says that directions will always stay the same. And so if it was down originally, it will stay down. The only thing that will ever change is axial and equatorial positions once you chair flip. And so over here we had down and equatorial, so the next one that we're expecting is down and axial. And so in carbon number 1, again, it stays down. This thing is pointing towards the downwards position, and so axial is going to be down. So we draw it straight up and straight down for axials. Over here, the arrow is pointing down, so down is axial, but equatorial is going to be with a little slant. So slant over here. In the original methyl group, it said we were going up, so we drew it on our chair confirmation going up, and that stays the same. And it was axial originally. So now we're going to be expecting up and equatorial. Again, follow these notes just to help you out with that. Again, equatorial goes a little slant. Let's see. Okay. C says which conformation is more stable and why, and label your interactions. So between A and B, I would say that A is more stable because it has the larger group in the equatorial position, which has more space. I would say that it avoids stronger 1,3 diaxial interactions because every compound has 1,3 diaxial interactions. So check this out. Let's see. So right here, carbon number 1, we go 1, 2, 3, and there's a hydrogen right here. And so there's 1,3 interactions, but they're weak because it's between a hydrogen, which takes up little space, and a methyl group. Over here though, we have 1, 2, 3. So hydrogen over here, there's two things on my axial position. It's hydrogen and it's also sec-butyl. And so even though hydrogen, again, takes up little space, we have a bigger group. And so this one right here has stronger 1,3 diaxial interactions. And so just keep that in mind when you're giving explanations. You're not saying that you're completely avoiding it, 1,3 diaxial interactions, or that one of them lacks 1,3 diaxial interactions. That's not what you're saying. That's not what you should be saying, because everything has 1,3 diaxial interactions. But you would say that maybe one of these compounds would have stronger 1,3 diaxial interactions in comparison to our most stable compound. And again, our most stable compound would be this one. I'll go through the wrong answers really quickly. Big one was always connectivity. So over here, when you draw carbon and hydrogen like this bond indicates that this carbon is bonded to a hydrogen. And so you kind of want to draw it like shifted a little bit. So this would be correct. Same thing over here. Over here, you're showing it bonds to the wrong hydrogen when you kind of spell out the formula. So just, again, you can shift it over and draw the whole thing. But the problem with this is that a lot of people would kind of put the formula incorrectly. So a lot of people did like CH2, CH2, and leave it like that. Or a CH2, CH2, CH3. And so that's like a whole propyl group. And that's not what we're seeing over here. This is a sec-butyl group. And so it's helpful to just draw things out. Like you just had a methyl group, and over here you want to draw your sec-butyl group. Because then you make sure you're not accidentally getting this incorrect. But if you choose to spell it out, try to do it right, and then show connectivity with it. For your flips, a lot of people kind of didn't follow these like rules where there's a wedge, and so everything on the wedge should go up on your chair, everything on the dash should go down. So make sure to follow those rules. The directions, they should stay constant. So for my methyl group, I'm expecting up, but it's down over here, so you know you're wrong. Sec-butyl group was going down originally, so it should go down over here, and that one was right. So this was the only part that was wrong. And then these at the very top, sorry for going backwards, by the way, but you should never have wedges or dashes on chair conformations. Okay, those are all the things that I can remember as like things that we were getting wrong a lot on the quiz. The reason I'm giving you guys this is so that you don't do the same mistakes on the test. I was being very generous when I was grading the quizzes, and I won't be able to do that on the actual exam. That goes for the explanations, because a lot of people said, again, the lacking 1,3 diaxial interactions, but that's not what it is. Everything has 1,3 diaxial interactions. Some interactions are just stronger than others. And again, I gave credit for all these explanations and things, but I won't be able to do that on the test. And so make sure that you correct your answers on your quizzes and you show it to Dr. Aguilar and Noah and I, so that you can get these right on the test.